Assalamu alaikum everyone. So today we have to start this chapter number 2, which is about the structure and synthesis of process flow diagram. So in the chapter number 1, we have seen that how we can develop the PFD and how we can develop the block flow diagram, process flow diagram, and piping and instrumentation diagrams, and what is an information that we should include in each of those diagrams. Now, in this chapter number 2, we have to take one step forward and we will see that how we can develop some process and what are the key factors that we need to include while we are making some process flow diagrams. So let us read with this one what we have in this chapter. So this one is a statement: the evolution of every process follows a similar path. For example, you want to make one product, you want to make some fertilizer, so there are some key raw materials that are required to make some specific product, right? So this thing is very clear. Now, what are the other options that we can avail? The resulting process will often be quite different, but the series of steps that have been followed to produce the final processes are similar. So for making one product, there should be fixed number of equipments that we need to have to make that product, right? Now, there could be some other options. For example, if you want to make that product in more efficient way, then maybe you can add some more additional product. You can have some better heat exchanger network, or you can have a better recycle. But the main units that we need to have that product, it should remain similar, but their position can change, and maybe we need to have some supplementary equipments like heat exchangers, separators, or some we can like play with the recycle ratio, so we can have different kind of process in terms of optimization, but the main units it will remain same. Now, what are the factors determining the choice of alternative routes? Okay, so we are making one product. So what could be the different alternative routes that we can have to generate the same product? So these alternative routes, they depend on these four factors. First one, the cost of raw material. So it is very important to have different raw materials to get the same product. So we have to see that which raw materials that we are going to use uh, to make some product. So what is an example here? For example, we want to generate the electricity. So there could be different raw materials for that process. For example, we can generate the electricity from the diesel based engine, from the petrol based engine, from the natural gas fired turbines, or we can have like some biomass or coal based power generation processes. So all of these raw materials, they will contribute to generate electricity, but depending on the use of raw materials, we can have the different route to get the required result. Then the value of the byproducts. So whenever we have some raw materials and we have some fixed products that we want to get from some process, there is also some byproducts that can be generated into the process. So if those byproducts have some economic value, that is a plus point, but often we have seen that there are some byproducts that are not of high economic value. So in that case, I mean, we have to see that what kind of byproducts we can have from that process, and if we have some other options to minimize the production of those byproducts. The third one, the complexity of the synthesis. Now, this complexity of the synthesis, here we have to deal with the better heat integration and better production of the products. For example, if you want to generate some gasoline from the crude oil, now there could be a simple process and there could be a very highly integrated process. So we have to see that which process can give you the product with better process economics while utilizing less amount of energy. The last one, we have to see whether environmental impact of the waste material. So the waste materials that we are getting from any process, so what could be the impact of those waste materials on the environment? Now, let us see what is the hierarchy of the conceptual process design. So there are five steps that we need to consider when we are making any new process. What are those steps? First of all, decide whether the process will be a batch process or the continuous process. Okay, so first of all, we have to see that we want to generate the products into the batch process or the continuous process, and what are the factors that we need to consider while selecting the batch or the continuous process. The second one, identify the input-output structure of the process. So we will see what are the raw materials we have and what kind of products we can have. What is an impact of impure raw materials on the product quality and how we can actually control. The third one, identify and define the recycle structure of the process. Now we can have different kinds of recycles in the same process. Maybe we can, it depends on the mass flow rate or the molar flow rate that we are recycling. So we have to see the reaction kinetics and what would be the impact of the recycle and what is the optimum point of the recyclation. Okay, so we will see that part in detail. Identify and design the journal structure of the separation system. Now, for the separation system, you know that there are different equipments that can separate the required products from the unrequired products. So we will see that one what kind of separation systems we can have to get the optimum energy utilization in the process. Then the number five, identify and design heat exchanger network or process energy recovery system. Okay, so whenever we can have any process, it is based on the energy that we are feeding to the process. Some processes they need less energy, but some processes they need more energy. So we are supposed to develop a process that can utilize the minimum energy while maximizing the product. Okay, now designing new processes. So whenever you're designing some new process, we have to follow this steps, step 1 to step 5. And if we are analyzing the existing process, for example, we are already having some batch or the continuous process, some industry is already there. So what we can actually do, we can analyze those processes. We will try to improve the heat exchanger network, or we will try to optimize the energy utilization. Then we will see what are the separation systems, if there are any new separation systems in the market that can have better process efficiency. For the recycle structure, we will see that, for example, if we are using some specific catalyst into the reactor, then maybe within the market there is some new catalyst that can have the better process performance. So we can play with this recycle structure. Then we have to see that what is an impact of the impurities that we can have in the feed and how it can impact the final product. So we can see that what is an optimum operating point of the impurities in the reactant side and what could be the acceptable product quality. Okay, and then we will see that if we can still have the batch process or we can shift towards the continuous process. Okay, so this is the hierarchy. For from 1 to 5 we can have the new process, and from 5 to 1 we can see analyzing the existing process. Now let's see the point number one in more detail and what are the factors that we have to see while deciding between the batch or the continuous processes. Now first one, the step number one, the batch or continuous process. What is a batch process? Batch process is one in which a finite quantity of product is made during a period of few hours or days. Okay, so the batch process, we need to have some fixed quantity of the batch with some specific purity, and usually that is usually taken that if we have the long period for a few days or few hours. Okay, then we can have just put the reactants together in the reactor, and then we will give them a lot of time to react, and then we can have the product. But in the continuous process is the one in which feed is sent continuously to a series of equipment, with each piece usually performing a single unit operation. So in the continuous process, there is a continuous feed to the system that can have the mixer, then it can have the reactor, then separator, and then purification also. Okay, so in one case you can have the continuous flow of the feed into the system, and we can have the continuous product from the system. However, in the batch process, we will just put the feed once into the system. We will wait for few hours or days, and then we can get the product. Now let us see what are the factors that we need to consider for deciding between the batch or the continuous processes. The first factor that we have to see here is the size. Now, the batch processes are more favorable if the production is less than 500 tons per year. However, for the continuous processes, these processes are favorable if the production is greater than 5,000 tons per year. Now, let's see what we have in the batch processes. A smaller throughput favors batch operations. So if we have a small amount of raw materials and we need a small amount of products, then the batch processes are more favorable. As throughput increases, the required size of the process equipment increases, and the technical difficulties of moving large amounts of chemicals from one equipment to another equipment rapidly increase. Okay, so for these batch processes, what is the issue here? That if we want to increase the production rate, then obviously we have to input large quantity of the raw material into a single equipment or the series of equipments, right? So if we want to increase the production rate, then we have to add up more equipments, and because those equipments are fixed, then when you increase the amount of the raw materials, then obviously you would require the larger equipments that will increase the capital cost of that equipment. However, in the continuous processes, economics of scale favor continuous processes for large throughputs. Now, for these continuous processes, what we can see that there is raw materials are not having the large retention time in the equipment. So the raw materials that are going into the system, it is converting into the product and going out of the system. So in that case, economics of scale matters a lot, and we don't have to have very large equipment to keep all of those raw materials together for very long time. Okay, so in the continuous process, we can have an advantage of economics of scale. The second one, the second factor that we need to consider here, it is the batch accountability or the product quality. Now it is you can just make a quick comparison that in the batch processes and in the continuous processes, the product quality is one of the issue. In the batch processes, we have some flexibility to control the product quality, but in the continuous processes, we cannot control the quality of the product a lot. Why is it so? Let's see this one. When the product quality of each batch of materials must be verified and certified, batch operations are preferred. This is especially true for pharmaceutical and food products. If reworking, reprocessing of specification product is not permitted, small batches are favored. Now, in case of the pharmaceutical industries and food products, where purity of the product is very critical and slight variation in the product quality can ruin the complete batch. Okay, so in those kinds of processes or those kinds of products, we have to rely on the batch processes. Secondly, in the batch processes, if reworking of specification product is not permitted, small batches are favored. So if in the batch there is some variation in the product quality and we cannot ignore that variation, then it is favored to have the small batches of those products rather than having a very big batch and slight variation could occur in the product quality and all the batch can ruin. Okay, so we cannot use that batch again. So in that case, we need to have small batches. However, in the continuous processes, continuous or periodic testing of product quality is carried out, but some potentially large quantities of off-specification product can be produced. Okay, because in the continuous process, the production rates are very high. So if there is slight variation in the product quality, what could happen? Large quantities of those products can be formed. Now, how we can actually control those products or how we can reuse those products, it depends uh, on the on the capacity that we have to keep those off specification products, and then we can recycle them or reuse them again. So if off specification material may be blended or stored in dump slop tanks and reworked through the process when the schedule permits, continuous processes are favored. Okay, so in case of the continuous process, if some of specification product is formed, then we have to store that one into some dump tanks for a long time, and then we will see our schedule that if we can reuse those products again somehow by recycling or blending with other chemicals to get the required quality. Okay, so it depends on the schedule, okay, to how we can actually reuse those products. Then we have to see the operational flexibility. Batch processes, often the same equipment can be used for multiple operations. For example, a stirred tank can be used as a mixer, then as a reactor, then as a stage of mixer settler for the liquid extraction. And now in the batch processes, what we can see that the same equipment, it can be used for multiple purposes. For example, you put the feed stock into one of the reactors. So at the first you put that one first you mix those raw materials into the mixer. So the same equipment is used. Then it is started acting like a reactor. So you have to give some retention time. Okay, so it will remain in the reactor for a few hours or days, and then it will automatically starting settling down, and then it can act as a liquid extraction. So the same equipment, it can be used for multiple purposes in the batch processes. In the continuous processes, operational flexibility can be built in the continuous process, but often leads to inefficient use of capital. Now, in the continuous or processes, what we can see that we have to continuously feed the raw materials that should give us the products continuously. However, if we want to have some flexibility, for example, if we want to generate some other product, then maybe we need to have an additional equipment on the same line. Okay, so what would happen that one of the equipment might be in use for the production of one chemical or one product, but if we want to get another product, then we have to use some another equipment that may be remained unused for the long period of time if that specific product is not required. Okay, so equipment not required for one process but needed for another may sit idle for months. That is one of the reasons often continuous processes are designed to produce a fixed suite of products from a well-defined feed material. So this is the main thing about the continuous processes. Why we have the continuous processes? Because they are designed to produce fixed amount of products with the specific product quality, and we have the fixed amount of feed material or the purity. If market forces change the feed to product availability and demand, then plant will be often be retrofitted to accommodate the changes. So whenever you make any process design for the continuous process, then it has to be like there is some criteria or the boundary that what should be the raw materials into going into the process. Now it will affect the reactor size, the separator size, the heat exchanger network, the recycle rates, everything, right? So if all of a sudden the production rate is reduced, so those processes cannot accommodate that change. Okay, so some retrofitting can be done to accommodate the market change, but this is not the issue with the batch processes. So if you need less amount of product, you can use a less amount of raw material, and you can handle those market changes. But here in the continuous process, we have to do some retrofitting with some new equipment. Okay, now the third factor that we can see here, standardized equipment, multiple products. Often batch processes can be easily modified to produce several different products using essentially the same equipment. Okay, so in this batch processes, what we can see that the same equipment can be used for different products. Example of batch plants that can produce 100 different products are known. For such processes, the optimal control and sequencing of operations are critical to success of such a plant. Now, in the batch processes, we can use one equipment for the production of one product, and after a certain time, we can use the same equipment for the production of another product. Okay, so in that case, because all of the products are connected with each other in a sequence. Okay, so for example, in the January you have to make one product, and in the February you have to make another product, and in the next month you have to make some other product. So in that case, you have to be very much dependent on those. So in case of these batch processes, you are highly dependent on the time, and you have to make a very fixed schedule to just incorporate all of the changes and to remain on schedule, uh, and to produce the fixed amount of product for that specific period of time. However, in continuous processes, the product suite or slate produced from continuous processes is usually fixed. In the continuous processes, we cannot change the products a lot, right? So we have to, so there is a fixed product suite and a fixed number of products that we can actually form from a continuous process. Equipment tends to be designed and optimized for a single or small number of operating conditions. Now, whenever we have the continuous process, we know what are the products, what should be their flow rates, and what should be their product quality. So, and all of those equipments that are used to form those products, they have some fixed specification, and they are highly optimized to meet those requirements. So if there is some change in the product quality requirement, or if there is a change in any feed, then it can affect the performance of the continuous process, and it will not give you the optimized results in terms of energy conversion, energy utilization, and even the product quality. It will be highly affected. Process efficiency, let's see what we have here. For the batch processes, operation of batch processes requires strict scheduling and control. So in batch processes, we talked already that we need to have a reliance on schedule, and so there should be very fixed or strict schedule and control on that schedule, because different products are scheduled back to back. Changes in schedule have a ripple effect and may cause serious problems with the product availability for the customers. So here we have to see what is the ripple effect. So if there is a delay in the production of the one product, then it will affect the production of the next product. And usually the batch processes are favored, and they change with the season, right? So in one season you may need one chemical, in the next month you may need to have another chemical. So because all of these processes are scheduled back to back, so we have to remain on the schedule to just avoid the problems of the availability of the product to the customers. If the same equipment is used to produce many different products, then this equipment will not be optimized for one product. So optimization of the batch processes is one of the issue, because we are making different chemicals in the same equipment but at different times, right? So we cannot optimize that batch or the plant or equipment for a specific product. Then energy integration is usually not possible, so utility usage tends to be higher than for the continuous process. Now, in the batch processes, we have to generate different chemicals at different times, so energy integration is usually not possible, and we have to just provide some more energy to the equipment at different times of the time, and we can have to compromise on the energy utilization in the batch processes. Separation and reuse of raw materials is more difficult than for the continuous processes. Now, in this case, separation and reuse of raw material is more difficult than for the continuous processes. So, when we study about the separation or reuse of the materials, we will see that how the continuous processes are more reliable, okay, because in continuous processes separation equipments we have, so we can play with the pressure, we can play with the recycles, okay. Now in the batch processes we don't have these options, so whatever we put in the equipment, we have to get the product after a specific time. We don't have any other options to play around in terms of separation or the recycle. In the continuous process, generally, as throughput increases, continuous processes become more efficient. So if we are dealing with the high production rates and high flow rates of the feedstocks into the system, then in that case, continuous processes are more reliable and efficient. For example, fugitive energy losses are reduced, the rotating equipments operate with higher efficiencies. Okay, so the energy conversion, the energy utilization, the pumps and the compressors that we're using for in the process, they work with higher process efficiencies. Recycle of unused reactants and the integration of energy within the plant or process is standard practice and relatively easier to achieve. So whenever we have some continuous process, we see that we can have the recycle stream, then we have an option to optimize the energy by integration different processes to utilize a better heat exchange in the process. Okay, so the continuous process, they have the advantage and that we can have an energy integration within the process, and we have an option of the recyclation within the process. The next factor that we have to see here, it is the maintenance and the operating labor. So in the batch processes, there are higher operating labor costs in standard batch plants due to equipment cleaning and preparation time. These costs have been shown to be reduced for the so-called pipeless batch plants. So in the batch processes, we have talked about that we can generate different products at different times of the year. So before making a new product, we have to clean all the equipments that are involved in the batch process so that it cannot affect the quality of the next product. So the operating labor and maintenance of the batch processes, it is usually higher than the continuous process. For the same process, operating labor will be lower for the continuous process. So in the continuous process, if you talk about the production rate, then we don't have to clean the units again and again, so that will reduce the maintenance and operating labor. Obviously we are fixed with the number of products in the continuous process, but we can have an advantage on the maintenance and the operating labors. The feedstock availability. Batch operations are favored when feedstock availability is limited. For example, seasonally, canneries and wineries are example of batch processing facilities that often operate for only part of the year. Okay, so batch processes are usually favorable when the availability of certain feedstocks are fixed, and those feedstocks are just available at the fixed times of the year. So in those processes like wineries, canneries, and even in the production of the sugar industry, production of the sugar from sugar cane. So sugar cane, it is we can have that sugar cane in the summers, and then winters we have to keep that one in the stock if we want to continuously operate that process. Now in the continuous process, continuous plants tends to be large and need to operate throughout the year to be profitable. The only way that seasonal variation in feeds can be accommodated is through the use of massive storage facilities that are expensive. Okay, so if you want to make any processor continues. So the example that I gave you for the sugar production. So sugar cane is usually available in the summers but not in the winter. So if you want to continuously operate the sugar industry or the sugar plant, then we have to store a large amount of the sugar cane into the storage facilities. So that could be an expensive part of the continuous process. Product demand. Seasonal demands for products such as fertilizers, gasoline, antifreeze, dicing chips for roads and pavements, and so on can be easily accommodated because batch plants are flexible, or some other products can be made during the off-season. Okay, so depending on the demand of the product, we can have the batch processes. In case of fertilizer industries, we can have the batch processes, or where it can be used for the production of the antifreeze during the winters, dicing chips for the roads and pavements as required. So whenever we have the option that we can have different products from the batch process, then we can rely on the batch processes to handle the seasonal effect or the seasonal requirement of the products. However, for the continuous processes, difficult to make other products during the off-season. However, similar but different products, for example, a family of solvents can be produced using the same processes through a series of campaigns at different times during the year. Each campaign may last several months. Now, for the continuous processes, although we don't have much flexibility to change with the product or the product quality, but we can generate the but we can generate similar chemicals by slightly changing the and the conversion rates, or we can slightly change the catalyst so we can have the different chemicals of the same family, or we can just play with the recycle rates and the separation processes, so we can have some slightly change in the product quality that can be required at different times of the season. Okay, but obviously, as we talked in journal, that continuous processes, we are very much limited to play with the product quality. Okay, the next factor that we have to see here, it is the rate of reaction to produce products. So batch operations offer processes that have low reaction rates and subsequently requires long residence time. Examples include fermentation, aerobic and anaerobic wastewater treatment, and many other biological reactions. So in the batch processes, usually we can have the batch processes if the rate of reactions are very low. In those, these are the examples for example, fermentation, aerobic and anaerobic wastewater treatment, so that require the longer residence time and the reaction rates are slow. So in those cases, we have to rely on the batch processes. In the continuous processes, very slow reactions require very large equipment. So if we want to have a continuous process, and the limitation that we have is the slow reaction rates, then we have to increase the size of the equipment, and we have to increase the residence time in the of the reactants within the equipment. So that would be an expensive way, and that can increase the size of that equipment. The flow through this equipment will be slow, and dispersion can be a problem if a very high conversion is desired and a plug flow is required. Okay, so this is one of the reasons that we have to use a very large equipment, and we have to be sure that the reactants, they can react together as much as possible, so the dispersion of those feedstocks over the catalyst bed, it is one of the factor that we need to see. Okay, the continuous process. Equipment fouling. When there is a significant equipment fouling, batch operations are favored because cleaning of equipment is always a standard operating procedure in a batch process and can be accommodated easily in the scheduling of the process. So whenever we are dealing with the batch processes, then we have to clean all the equipment before making a new batch, right? So in that case, if there is some fouling within the equipment by during the production of one product, then during the cleaning, the fouling is removed from that equipment, and in that case, it will not affect the next batch. However, in the continuous process, what we can see, significant fouling in continuous operations is a serious problem and is difficult to handle. Now, if there is some fouling in the continuous process, we cannot remove that equipment from the process and clean it, right? So, fouling, if there is some fouling in the continuous process, then it is a very serious issue. Operating identical units in parallel, one online and the other offline for cleaning, can solve this problem. Okay, so here you can see that if we are dealing with the chemicals that can cause the fouling, then in that case we have to use the multiple equipments on the same line, and in which one of the equipment is in use and the other one is in under the maintenance. So as we want to have the continuous process, we have to increase the number of units parallel on the same line to avoid any closure of the plant. Okay, so we do not we don't have to we have to just operate the plant continuously. We cannot stop the plant. In that case, we have to put several parallel units on the same line. However, capital investment is higher, additional labor is required, and safety problems are more likely. So in that case, we have to increase the number of equipments. That will increase the investment. Additional labor is required, so instead of handling one equipment, now we have to handle more than one equipment, so we need to have an additional labor, and safety problems are more likely. So whenever there is a maintenance, so we have to see that how different equipments can be connected with each other, and we have to one of the process is operational on one equipment and the other one is under the maintenance. So we can have some safety issues while conducting the maintenance over those equipment. Then comes the factor for the safety. Generally, worker exposure to chemicals and operator error will be higher per pound per product. Then for the continuous process, operator training in chemical exposure and equipment operation is critical. In the batch processes, we saw that every equipment needs to be cleaned just before the start of the production of the next product. In that case, the operators that are exposed to the chemicals during the cleaning, it is very high. Okay, so from the safety point of view, the batch processes, these are not safe as they expose the operators more towards the chemicals. In the continuous process, large chemical plants operating continuously have excellent safety records and safety procedures are well established. For the continuous process, the labor or the operators, they don't have to come into contact with the chemicals again and again, and there is a specific safety procedure that is being adopted whenever some maintenance is required. Operator training is still of great importance, but many of the risks associated with opening equipment containing chemicals are eliminated. So here again, because the operators, they don't have to come into contact with the chemicals again and again, so the safety of the operators are usually high in the continuous processes. Controllability. So in the batch processes, this problem raises because batch processes often use the same equipment for different unit operations and sometimes to produce different products. The efficient scheduling of equipment becomes very important. The control used for this scheduling is complicated. Now, in terms of this controllability of the batch processes, because different products are fixed with the time limits and different times of the year. So scheduling it is very important for the batch processes, and it can highly affect the product availability to the customers if there is some change in the schedule. For the continuous process, generally continuous processes are easier to control compared to the batch processes. Also, more work research has been done for these processes. For complicated and highly integrated plants, the control becomes complex and operational flexibility is greatly reduced. So usually for generating of some simpler products, the continuous processes are more easier to control compared to the batch processes. And if you see the literature, more research has been done to make the processes in the continuous fashion. However, if we are dealing with the complex and the highly integrated plants that are generating more than one products, and if there is an optimization between different equipments or the heat exchangers, then in that case, the continuous process operation become more critical, and we do not have much operational flexibility. Okay, in that case, we have to be just fixed with the requirements of the process, and we cannot deviate a lot with the process conditions. This is one of the issue with the continuous process. So this was the part, the step number one, and we have seen the difference between the batch and continuous processes. Next time we will start with the step number two, and we will see what could be the impact of process input, which is the feedstock, and the output, which is the product structure. Okay, and how these input and output structure of the plant can affect the overall process chain. Okay, so we will study this one in the next lecture. Thank you.